Alright, Chapter 37, Using Imported Geometry Direct Editing Techniques. Dealing with geometry imported from other CAD systems is often difficult, particularly with a history-based system. Imports aren't always clean, meaning they often need repair. Sometimes you might want to change the imported data, often called the dummy geometry, because it has no feature of the imported data. It can be edited with the direct editing tools and techniques. Direct editing tools, Solidworks enable you to change part without having access to the history view features created by the part. However, they do create the history-based features within Solidworks. Direct editing works on both native and imported geometry, either by simply moving faces, editing geometry directly, rather indirectly with a feature in defining the sketch. The chapter looks for the imported export tools available to Solidworks and the direct editing tools that can be used to manipulate and import in native geometry. In this chapter, you will learn to understand imported geometry works, examine the traditional role of the direct editing tools, to prevent for the direct editing tools, import, repair, solid geometry. Understanding basic imported geometry, geometry for the transfer over the CAD package. This is imported geometry for the transfer that usually happens with the Initial Graphic Exchange Specification, pronounced IGS. And STEP, Standard Exchange Product. Parasolid, ACIS, are the names initial for the three people who created the standard of the Alan Charles Iron system. Format. Solidworks also reads some native CAD directly. For example, Solidworks can read directly versions Pro Engineer, Unigraphics, SDRC, Inventor, Solid Edge, CAD Key, Rhino, as feature 31 shows. In most cases, features that are transferred between CAD patch geometry will wind up with what is called the dummy geometry, because the list of features that model has the parent software is no longer there. You can import data with the two ways. The most common way is to use the open dialog box, switch the files of the type, and import the file of that format. The other way is to use the imported geometry feature for the choosing the insert feature for the imported geometry from the menu. The open dialog box straight with the new part imported feature for the top of the feature manager shown in 37. The imported geometry features enables you to insert imported geometry anywhere whether you like with the feature manager, even after the feature has been added. 37.1, Solidworks open the neutral files as well as the native formats. You have drawing, Adobe, Illustrator, lib format, feature, liberated feature part, temporary parasol, ego, steps, ICS, ACS, VRDM, mesh file, 3D, manufacturing format, Cadia, graphic, Cadia V5, Solid X, ProEc, Creator, Unigraphics, Inventor, Assembly, Solid Edge part, Solid Edge key, Solid Edge part, Solid Edge assembly, key, CAD key, add-ins, IDF, Rhino, and JT. Imported geometry comes without any features in the history. Use data mitigation with the command manager for the find tabs to support the imported geometry tools available shown in 37.3. Remember, the tools aren't directly related to imports. Most frequently used to import by feature works for the part of the Solidworks professional bundle and is beyond scope of the value of the mentioned within this part. One possible workflow for the editing and imported geometry toward the end of this chapter. You see Solidworks data mitigation table. The command manager helps you to find import. You can open import diagnostic check, the graphic analysis, recognize features, hide heel edges, knit surfaces, move copy bodies, delete face, delete face, replace face. Using Solidworks in 3D interconnect. Solidworks 3D interconnect enables you to treat imported documents as one directional inbound associated with the original native format file. The means that you have imported the Autodesk Inventor file, you have the 3D interconnect, interchange the change of the file Inventor. You can update with the imported geometry in Solidworks. Chain with the parts of the Solidworks cannot be sent back from the link of the original native Inventor part. With 3D interconnect functionality is supported for the following system: Cadia 5, Autodesk Inventor, PTC, and Solid Edge NCF software. The functions turned on the default standard of the Solidworks 2017. Control the setting of 3D interconnect tools options. Import when a part is used in 3D interconnect, it comes with the arrow symbol that connotes external links. The external links works by first the dummy body geometry from the native file. Much of the parasolid body is stored in the Solidworks part, then re-importing the body from the change file of the better to get the body data directly for the native file that it goes to the translated for such IGE and even step. In my opinion, the biggest advantage is using the 3D interconnect. Their claimed associated links are somewhat dubious. Primarily, Solidworks imported data is being saved internally with the parasolid body separate with the Solidworks part. There's no real link to the native format file since they are used as native solid parts of the actively open links in Solidworks assembly. Alright, secondly, you're able to have been able for some time to do this re-import with the 3D Interconnect simply with the editing format, definition function, imported data after all of the functionality Solidworks, you the behind the scene with the automating, somewhat give it the fancy name, whether they're more or less of the work, either the so-called associated nature of 3D Interconnect is you decide. Again, my opinion is because of some of the direct CAD packages that are import with the direct data directly, the data Solidworks are not able to do that. Usually will be later in this chapter. Solidworks probably developed with the need of the answer lack of the functionality, even though the answer predominantly smoke with the mirrors. Anything little practice ensure that importing data with CATIA can be challenging. 3D interconnecting extra solid body data, converting parasolid, likely most reliable way to create CATA IAV5 data. This chapter is written the assumption 3D interconnect has been disabled to work with the exercise intended. I recommend that you turn 3D interconnect off until you think you need it. Getting experience for import. Solidworks import data with another CAD program to resolve the imported feature for the feature management. For example, 37.2 situation, typical linking with the result of a single solid body. Frequently, imports does not come in this cleanly. When imports start giving you trouble, you see the error, single body, possible multiple bodies, or even the surface body. Solidworks can address some of the type of the error that automatically can address. So manually, from time to time, with various reasons, you might get such a messy part that you want to try the different method of import. For example, the different import or export settings, a different file type. Best way to start and feel comfortable with the imported data, expose the wide range of files. Some of the work, some that don't. The chapter is intended to be a short course on the import repair, but repair is certainly part of the reality working with the imported data. Understanding the results of the import when import geometrical data with the Solidworks can get several different types of results. Single solid body for the part file assembly with multiple parts, multiple solid bodies in a part file, surface bodies in a part, combination solid surface bodies in a part. When you get an assembly of the part Solidworks, you have the default template, which you have the designated in the tools option. Default templates created the new parts, save them onto your hard drive automatically. Some imports create report files, extension of the RPT and error files include statics of the entity with the precision data file name, units, origination system, and information of the errors occurred during the import. Figure 34 shows the first section of the report written and imported the IGES file. Reports can help find, understand concept, and import. Demonstrate that some of the data import a few parts that don't come in perfectly. Also, you can follow along with the fill-in material, the downloaded material, the website. But this is much to click by click tutorial. Watch over my shoulder demonstration with commentary, starting with the parasolid import with the parasolid fastest and easiest. Open up part chapter 37, the robotic arm XT. Download material 37 that you can open with the translated formats for a couple of ways. May look for the import translate option file menu, but it's not there. You can use the open command and select parasolid from the files without type drop down list. Then that's the way but that's the slow way. I prefer opening translated file using Windows Explorer, dragging and drop the file open onto Solidworks window. After you open the window, you'll notice a couple things. The first thing in the standout, you move the model display shaded mode, regardless of the way you have it displayed with the displayed set. For example, I'd like to use shaded with edges, but imports always set it back to shade. Next thing to note, the imported one feature of the menu for management. In this case, the import clean there, so no warning yellow triangles, arrow, red circles. This isn't a good indication. This is always a good indication of the state of the part, though. They must have some errors in Solidworks known as aren't displayed with the imported feature icon. Investigate closer. Right click with the imported one feature. Select the import diagnostic. Import diagnostic. Evaluate tab. Command manager. In this case, if the model really clean, running an important diagnostic. Only way you can really know the figure 37.5 with the feature manager import diagnostic part itself. Next, open the parasolid file called the bad face XB. This one also imports you without an error. Warning import failure, but there is clearly a missing face. Easier to visualize with a separate face of the parts. You change the display mode with the shade with the edges. If you examine the part closely, you can see the several faces aren't lined up square with the rest of the part. Notice there are small sliver of faces. They may be intentionally or may be part of the problem. Triangular faces, sliver faces have very sharp corners, usually long and narrow, and are often source of the error of the translated parts. Alright, parasolid imports tendency to be the fast, trouble-free. Right-click import. Here, under the import diagnostic sheet with the fault face list with the click of the attempt to heal with the all button with the fixed fault face. Figure 37.6 show the part within the fault face. Now open the Pro Engineer with the file called the bad face 2 part. 29 Pro Engineer files are often version number of the very extension, but you need to be careful to see the file that looks for the Pro Engineer file with no conversion extension. Solidworks sheet of the Pro extension for the first couple of years, but it's still open to the type of the file as a native file. You can still find some of these parts of the circulation. Open file, you the import geometry directly open with the option with a split with a shaded with the edges running an important diagonal of the part of the bad face with this click, the face of the faulty face lift. You can see with the face of the next two small point triangular face showing the 37 attempt to heal all the options. Okay, takes care of the import same file, but the time chose to analyze the model completely option with the show that tells you to recognize 13 out of 13 features. Click on the feature button, watch for the parts, rebuild the benefit. This time part comes up with the feature error, but the error is on a fillet, and it was the intact from the previous error, but it was on a face next to the fillet face. Next to know the parasol parts come up almost immediately to the Pro Engineering parts that take several seconds to process the data. Imported files become larger and larger. Branch and assembly difference processing time becomes more and more pronounced. Three-sided silver face is often the source of the error of the imported parts. So we went to imported part diagnostics. Found a faulty face and then attempts to heal the face. Importing the same data but a different way that gives you the different results. Message analyzing fault face. Next is sheet metal. With the open sheet metal XT with the chain with the display shape with the edge of the parts look good and import with the diagnostics said that it's okay, but because this is a sheet metal part that appears to have a consistent thickness, they'll try to play and then click the sheet metal command manager tab. Click the insert bends icon with the far right side. Select the big flat face with the face to remain stationary in the top selection box. Check with the green check mark button to accept the result. Sheet metal features are added to the part with the button with the figure 37 and 8 have it then failed with a close inspection part reveal with a smart ledge between the big flat face and the inside bend of the both ends, probably modeling error rather than translating error. They may not be able to, and you may be able to fix this, make it unusable with sheet metal part imported geometry editing. You'll need to go to the end of the chapter. However, I cover the result of attempting to repair this model. Last part I want to show you, the watch over my shoulder. The demonstration is the part with the complete log of the IGES file that came from Autodesk Mechanical Product. The download materials open the file called the valve body IGS. This part takes several seconds to import, but when it does import, it has 10 surface bodies, doesn't face errors, and some of the obvious problem with a couple of faces and somehow became out of control. This is one of the reasons some of them either don't recommend IGES files. Type of the error is more prevalent. IGES files are other than formats. Figure 37 to 9 show the feature manager of the part on the screen. Again, notice for the location where the huge problem faces come off of the model are pony triangle faces. So we have these analyzing faulting faces of 77 and gaps between faces of 50. You can attempt to heal all faces, attempt to heal all gaps. Very often you will find the import result between the various SolidWorks different. For the example of SolidWorks 2008, the valve body imports with enough success that you might be able to model over the surface of the bodies, eventually piece together the original model. Earlier versions didn't get that choice. Alright, note that the error shows there is no points there are no points that exist in this file. When you import the IGES file, probably because you have the scan to 3D selected to add in unless the IGES one of the accepted file types to bring into the point cloud data scan to 3D assumes you're trying to use the IGES for that. Scan to 3D is added and comes into the SolidWorks Professional, not within SolidWorks Standard. And beyond scope of this book, with the disable it, choose the tools, add and deselect the check mark with the box and scan to 3D. If the pair is that is bad, you first move that should be try to get the better data from the score that isn't available. You have the uphill battle trying to make this part work. Automatically hang with the import diagonal with the going when the test of this part of the repair is going with the beginning exercise manual surface modeling. If you don't have the patience for that, you could try with the surface modeling with the reference phase with the part that it could closely interact with some of the fillets or the would be surprised with the translation failed so badly. Many of the fillets are badly hacked together. In addition with the casting, someone goes beyond going into the needs of applying the draft to the part with all the fillets on it and parts is going to lend itself to that very well. Handling import errors. Import errors are usually covered the difference between exporting import CAD software vendors. Some imports more prone to errors than others. For example, the IGS format is interpreted different with the different software vendors and very prone to the errors. Another type of error due to the tolerance accuracy issue with the CATIA is notorious for having very large tolerance to export data that enable the CATIA to work with large data sets more really easily, but it means that the geometry is when the geometry is read into SolidWorks, it typically requires more accurate data You can see lots of error. The fact of the CATIA into SolidWorks translation is one of the most problematic in the CAD industry. Seemingly odds because the SolidWorks and CATIA are both owned by Dassault Systems. Both difficulties have persisted for more than a decade, so it isn't a technological difficulty, it's a business decision. Repairing importing errors automatically. SolidWorks have a tool called Import Diagnostic. Import Diagnostic can run automatically, manually find error with import data, but to make the repairs if possible. You can access the Import Diagnostic, right-click the imported feature of the feature manager as long as there are no relative SolidWorks features that follow the imported feature. Pick the CH37 show the typical result with a faulty import. Sometimes the errors Import Diagnostic finds are things that you can see such as missing faces. Sometimes these things you can see like the edge of the face that don't intersect, or inconsistent face normals. When errors can be found and repaired with the Import Diagnostics, the best way to go. 3710 show the Import Diagnostic helps you find and repair errors imported. Analyzing faulty faces, gaps, repairing import errors manually. Some errors are bigger than the Import Diagnostic cannot fix them. Example of this type of error with the facing missing altogether the imported data within. Something like this happens. One thing you can do the restore the for surface model import leaves that import leaves you with surface bodies you can repair with automatically. You must be able to remove the bad face, replace the new face that you construct. This is all about surface tools to create the new face, the extruding, possibly trimming the new face to fit the gap caused by the bad face and face, knitting everything together back into a solid. This becomes an oversimplification workflow. Manual import repair was essentially a big picture of steps that must go through to get the task done. Some models models aren't bad that you can fix. They won't be made. They wouldn't be worth your time to fix. If the automatic repairs don't work, simple manual repairs don't work. The next thing to do is to go back to the source of the file and ask for better data. Alright, whenever the export data is good, another CAD system consider the best practice for the professional curves for the round trip save out reading back data, make sure they can accurately read the data you saved. If you get bad data, you don't have the access to the source. Automatic or manual errors prevent you from using the data. The next best thing is to rebuild the part using error-filled data as a reference. This is never a pretty thing, but if you really need the data to be clean, there's no other way than this is what you need to do. So, take a measurement of one file, build a new part with another, build one file in the context, assemble it directly over the problem, even rebuild it in multi-body part. Tricking data into working. Occasionally you can employ trick to heal the problem. Import simply saving it out with the SolidWorks as a parasol with reading back and repeatedly come in sometimes heal troublesome imported geometry. Or frequently use the Rhino to import problem files, then export them from Rhino to parasol. Rhino is an inexpensive application. You can read more about it in www.rhino3d.com. You can download and install the trial version that allows you to give you up to save 25 times. Rhino works great as a translator because it reads and writes many file types that SolidWorks does not read. Sometimes when I get back very bad IGES files, I read it to Rhino and save it out to the parasol, then I read the parasol to SolidWorks. Sometimes the repair data is up to the point where the SolidWorks can deal with it more effectively. This doesn't say Rhino is a better file translator than SolidWorks, but because it works around, doesn't always improve things. It's sometimes effective because it's free. The only thing to do is trying to cost you at this time. Or ensuring good data. If you can't get SolidWorks file with someone who needs to send you data, type of the translation file that you do not. You have a huge influence likelihood of your translation will be successful. Ask for the data in this order. Parasol, including the native form of the parasol, such as the NX unit, graphic solid edge parasol, comes in text format and binary format. You may also see file extensions such as XM and XMTTX for older version unit graphics. Over these binaries are small, but the text files have WordPad readable, editable headers that can be useful in various situations, such as correcting units, part scaling, as well as telling the parent CAD program what was. CATIA does not export parasol. CATIA users may save the step, then download and install free step parasol converter to generate parasol file. Your AP214 and AP203. AP standard the application protocol. Most mechanical CAD programs use the two protocols which develop the automotive configuration, control the design, read more steps, tools, library standards, step 2 to HTML. ACIS creates SAT files, VDFS and VDA, the German automotive Geometry Transform Format, IGES. Because of the age and lack of a clear definition, IGES format, little about it is truly standard anymore. Many geometry creation software packages exploit data that SolidWorks cannot read correctly. Although this format standards for the old timers, one problem you want to avoid unless you're getting data from someone you know will give you something usable. Another advantage of Parasolid data is SolidWorks reads it quickly. A large IGES or step file can take a minute to read. SolidWorks can read equivalent in Parasolid data with a couple seconds after the data read. But the SolidWorks should be able to be the same with no difference between the data with the Parasolid and any sort with other source because it's all converted Parasolid to be stored inside the SolidWorks file. Parasolid reads very quickly and so it saves time. Whether or not data receive the value, it depends on the part of where you want to do it, but your data in visual representation, not a CAD accurate, non-uniform, rational B-spline model. You may be able to accept the wide range of the data types. If you're looking for the manufacturing quality data dealing with some formats simply not worth your time, the following types of the mesh data SolidWorks can read are useful for visual data, but useless for cleaning up non-uniform, rational B-splines. STL stereolithical graph, typically used for rapid prototypes. VRML, virtual reality markup language, typically used for the game's old format that allowed color to be transmitted with the mesh geometry. CGRL, CTIA graphics, converting point to cloud data. One of the most common import questions is how to import data from the file format such as object and 3ds, among others. The file types of the mesh file, which mean with a simply point cloud data. SolidWorks and most of the other CAD programs create geometry that is not uniform rational B-spline data, where surfaces are represented by very accurate mathematics. Mesh data is represented with the path of the points in space, which is much faster to work with because of the similar data used in this graphic card with the driver's display with the curvy shapes. Mesh data is used by Hollywood video game developers, Computer Graphics Studio. National Uniform Rational B-spline data is used in engineering and manufacturing. It's easy to convert National Uniform Rational B-spline to mesh, but it's more difficult to convert mesh to National Uniform Rational B-spline. Mesh to National Non-Uniform Rational B-spline conversion can be done more complex software and specialized expertise needed to happen correctly. Alright. SolidWorks can make it a mesh for the National Uniform Rational B-spline conversion scale. The 3D software because there's included the standard packet. The BM scope of the book isn't covered here. Understanding the traditional role of the direct editing tools. Traditional direct editing CAD software has lived within rule with the grade with the geometry shouldn't affect the height of the edge of the geometry. Therefore, direct editing CAD packages still use the function like extrude and revolve to build parts, but they won't return with the function to edit the part, but instead of the direct manipulate the face of the part, moving, offsetting, and rotating. CAD software depends on the direct editing tools that have existed in the world a long time. Some of the direction editing CAD projects have appeared within Steam that have renewed the interesting of the direct editing techniques until some of the recent resurgency of the direct editing programs were seen the old-fashioned, interfering parametric history-based programs. One way to think about direct editing is leave the intelligence in the software and history-based techniques, so you put the intelligence in the data. Technically, what SolidWorks does when it works with the imported feature list geometry is not direct editing because it leaves the trail with a history-based feature behind, which is very much opposed to most of the benefits you get from the true direct editing tools, such as the lack of the rebuild time, lack of the history of the tree, and so on. If you want to research the direct editing in the form of the synchronizing technology developed by Siemens PLM, you can find them in the free short book of that I wrote with them on the topic of the HEPS WWP PLM Automation Siemens Company.com in English, companion single top of the TFM component 247520 and component template 8186312. History-based models are still popular with you to design things. Much more the story because of the direct editing scheme. The more some weakness, there are situations in which the certain edits cannot be made straightforward with a reversing set of edits that does not result in the original configuration. The background information is an important part of the overall decision in place for these tools as SolidWorks software. Adding direct editing tools SolidWorks isn't an earth-shattering change, but it's secondary important. The direct editing tools SolidWorks are a bit odd because the direct editing stands on opposite of the history-based techniques and SolidWorks direct editing tools. Within the history-based software, you do not really get all of the available benefit of the direct editing when it's done instead of the history-based method. Okay, understanding the strength and limitation of the direct editing tools and software. Some of the selling point with the direct editing CAD tool that they don't have to worry about with how the parts were made. Just make the changes you want to make. The feature of the tree, with the history, with the always include the feature rebuild. With the user that tend to complain about these rebuild taking a long time, especially with the large parts and assembly. With the tap with the grappling feature or with the feature rebuild with the times of problem. Solidworks user face lately often complain about their direct editing strength. With the feature order problems are avoided. Rebuild time is avoided. Change with the more intuitive, being geometry based rather than logical based. Having something was made doesn't matter. Probably the most serious limitation of the direct editing tools is that after a face has been eliminated from the model, you cannot bring it back into using more direct editing tools. For example, consider the part 3711. If you change the bottom of the square of each of the areas, such as the flat face between the bottom square of the arc disappear, you can get it back by just moving the face back to where it was, or you would have to move the face and then cut it to reinstate the flat face. Limitations left. So here's the direct editing tool. Just another tool, history-based modeler. Because you can resort to more powerful history-based tools. Compensate will be dedicated to direct editing only. You'll be up against a more difficult task. Alright, 3711 limitation of the direct editing. Other limitation of the direct editing CAD software have to do with they were related to the feature of themselves or some sort of the process. Such as fillet shelf, the extrude sketch text. Although fillet and shelf, they have two more probable features for the history-based modeling. There are two features that create the biggest limitation for the direct editing software. Alright, using Solidworks direct editing tools. So how does Solidworks history-based system incorporate the advantage of the direct editing technique? Not practically throughout the history-based. What does it like contradictory regime collide? Starting sharing ideas. Solidworks has been taking ideas from history-free schemes, according to them in history-based schemes. First 11, I'll show you how it works. In a simple example, you the part with figure 3711, 3712. So feature manager original sketch. No, the original sketch hasn't changed, but the part itself has. Rolling back to eliminate the move face feature. Making change with the original sketch. Change with the starting point of the move face feature that are unrolled. You may be able to imagine the part with a much longer feature tree, with the relationship between the face of the feature, the more complex overriding the complexity by editing the face directly could have some appeal. So we're now direct edits for the history-based part using move face. When it comes down to the direct editing capability, Solidworks primarily represent the move face feature. The other feature for the delete face, some of the body transformation tool for the move face is primary tool. Move face enables you to move, offset, the rotate, translate selection of the face that does not have corresponding to any features. They don't have any of the connect as long with the translating, rotating selected face that can be extended with the trembling neighbor or face to move the face. Probably work limitation must often cover the move face edits and then fail with the tendency that it can extend with the situation and require the new face to be created. For example, 3713 show for the top of the section imported rivet being moved by the move face tool with the required selection of 48 face to do with this dragging along with the graphical inner face. Figure 3713 show for the move face tool in action. Because of the imported geometry editing, something other than the cut and add with the geometry, move the face with the direct editing with the real, something different but extremely powerful that works well. This way you need to have the initiative of the graph with the non-uniform or rational B-spline with their BREP model, but you do not have to worry about with the face of the control with the feature with which sketches drive with which feature just select the faces you want to change with the tell with the software how you want with the change with at least for the concept of the traditional direct editing software. But I mentioned that earlier, Solidworks not traditional direct editing software, history-based modeler. Solidworks can still do this ahead with the true history based with the model fashion. It has to record edits feature with the true edit direct editor would not. This means with the command conflict which would come with the Solidworks direct editing. Solidworks can do some of the direct editing functions, but does it very non-direct editing and non-direct edit sort of way. Combining direct editing with the history, the Solidworks have several features that do not create new geometry for the editing of the existing geometry only with the new native is imported. This includes the tools of the direct editing tab of the command manager, shown in the 3714. Tools of the direct editing tab of the command manager. You have move face, move copy, devise, fillet, chamfer, linear pattern, delete, keep body, delete face, split, and combine. And that's in the direct editing command manager. I'll show the slightly more complex example of the traditional SolidWorks. If you wanted to move the face indicator with the 3715, you would go back to the edit of the sketch. For each of the move that you used to create it, this would be easy enough. The filters would update with the match of the geometry. So we make the longer band on the moving of this face. The pilot greatly complicated the direct editing scheme. A proponent of the direct editing software would say with the first finding with the feature with the chain with the chain with the difficulty, then waiting with the unbuild with the model back to the sketch, then waiting for the chain with the rebuild, all feature for the after the sketch is complete, finally dealing with the downstream feature with the like of the field with the field data failed to do the chain with the frustration, he would be right. You can find the feature of the tree with the right click with the geometry for the graphic window with the select with the go-to feature within the tree. The problem in this part is shown with the alerts of the lifting cannot be trained with all the traditional direct editing scheme. With the direct editing scheme with the first fillets that adjust the face, they aren't intelligent feature, they move the face that are attached to it. You have to also explicitly tell the fillet faces what to do. While the direct editing implementation software such as Solid Edge is smart enough to make chain with the models and fillets on them, the direct editing tool of Solidworks are less sophisticated and cannot deal with the fillets as at all. However, to simplify the parts and suppressing fillets and use the move face feature of the change of the parts of feature 3716. In order to do this, you will have to make sure that no fillets features have shown other than the other fillet feature that have to suppress the fillets and move the ring around the top of the barrel as well with the mounting boss. So the web extend above the barrel. Move the face extend with the length of the barrel cast part after the fillets have been removed. In order to make this move, I had to select 7 faces: top of the ring, bottom of the ring on the left, bottom of the ring on the right, top of the boss, bottom of the boss, full around with the end of the boss, the hole of the mounting boss. Notice how the web now extend with the upside of the barrel. With this type of the edit with the file with the clumsy Solidworks history-based tool, if you would have wanted to do an indirect edit, it's kind of the edit that would be clumsy if they were not what you wanted to do. This is one of the limitation direct editing techniques in general, not limitation Solidworks, but limitation concept and implemented in Solidworks. Figure 3717 show the weakness of the direct editing tools in Solidworks begins to show up. The first feature of the part that revolves the the sketch. The last feature in the part is a move face feature for the move of the face of the grave by the revolve. So you want to change the geometry of the barrel, but it's controlled by the 2 different features. If you make a specific side with the move face feature changes it, move face can change only relatively to a starting point, but it cannot make something specifically dimensioned. So move the face feature, some of the geometry double jeopardy become the chain of the 2 different. We've turned the revolve sketch 2. Some SolidWorks power users consider the double jeopardy condition sloppy design or bad practice. You can make strong case of the direct editing tool should not be used on native SolidWorks parts, but you should edit the feature from the way that it's created. This is certainly a place for the argument, but I know from my own modeling work that sometimes changing the feature way back in the tree can have the unintended repercussion later in the tree just due limitation history-based modeling. Use the move face feature late in the tree, avoiding fixing lost propagated errors in this cheap, sleazy cheat. Isn't this cheap, sleazy cheat? You will have to decide that for yourself. Combining direct editing with imported geometry. Regardless of any argument against the direct editing tool with the native SolidWorks data, there can be no such argument against you with the imported data direct editing tools may have a limitation, but when dealing with the imported geometry in SolidWorks, your choices are limited to see what you're following. Your direct editing tools, your cutting, adding, modeling, manual surfacing tools, feature work, and deconstruction. When faced with this option, the direct editing tool looks like a safe choice. The big problem is that the part is covered with fillets. You may not be able to change much. In this case, likely you might be combined to an each of the tools, such as feature works, to remove the fillets and then directly to edit make changes. Tutorial importing repairing solid geometry. Tutorial works through the buttons. Click on the import CAD data IGS. Even from some edits from download data, open the CAD covered IGS. Open the file with the selecting it. Open dialog file. Open drag and drop it in from the window explorer. Right click and import a feature for the run import diagnosis. Know the import diagnosis. Find those error on the part. Look at the inside of the part error and the of the part origin. Know that one over the end of the tab of the fill is coming to a point. Show them the 37 and 18. They're clearly not right. Although import diagnostic didn't identify it as a problem. Open and sketch flat face for the switch for the tab protrude with the right click with the edge of the tab with the initial with the sketch face with the select with the tangent, then click with the convert ending with the toolbar with the click with the green check mark icon to accept the result exact for the sketch. Right click one on long face with the tab, select with the tangent with the then select all to the top of the serve the face with the tab, and there are 16 faces all together to activate the delete face feature. So the delete patch option with the select within the 2 remaining face with the tab with except the result of the model should remain in solid mode. The tab should be replaced by a smooth face. So with the sketch created with the step 4 extrude with the blind depth of 5/100ths of an inch. Apply a filler around the end of the face of the radius of the 10/100ths of an inch. Activate the mode face feature to select all the faces within the 2 side tabs of the snap of the feature. End of the U with the translate option. Right with the X, Y, Z plane in the direction of the U with the distance of 1/4 inch. You should have not less than 21 faces. Select the face with the arrow pair will to translate. direction you do not need to be selected because they're automatically extended and trimmed to fit with the habit of troubling setting with the right face of the rat refer to figure 37 to 19 open and finished part from the download materials on the website called Tutorial 1 Finished Solid Part. Moving tab, snap, and then single move the each face feature, save the part with the under different name and exit. Tutorial Flex and Freeform tutorial steps of importing editing geometry for the move of the face flex freeform feature for Solidworks. Open the parasite file with a wildly website with the ellipse exit E with the inscrete for the side of the part with the move the face feature for the offset option and can enter the offset of the distance appropriate view of the property manager. Use the offset of the distance about 0.08 of an inch. Make sure only the elliptical face of the model is selected to activate the flex feature. View the following settings. Show figure 37 to 20. Select the volume of the graphic window with the top selection box. Use the bending option flex input section. Use the hard edge of the flex input section, and then select 190 degrees from the angle of trim plane 1 to the distance at 1.9 inches of the trim plane 2 with a distance of 4.5 inches. The step of the feature when you're finished. Open the sketch with the XY plane. Orientate the view normally. Then sketch an ellipse on one end with the major axis of the origin. Rest of the dimension is shown in figure 3721. Sketch an ellipse. Initiate split line, insert the curves and split line, select with the bent face of the part with the step of the feature when you're finished. The split line option splits outside of the inside of the curve face. If you select the shade with the edge of the, you can see the split of the both sides. Create show the XL assembly table. Initiate freeform feature of the select with elliptical split face for the outside of the bend. Created with the flex feature for the direction 1 symmetry option. Gray plane should appear on the right of the YZ. Click add the curves button. Snap curve for the symmetry plane. Click add for the curve for the symmetry plane. Highlight orange when selected. Add a second curve parallel to the first one about 1/3 on the way with the symmetry plane with the edge of the split. Click with the add points button to place the point approximately as shown on the 37 to 22 for the point and second curve of the approximately same location of the first point for 37 to 22. Show the one end of each of the curve. Click add buttons point to deselect it when you are finished. Change continuity flag point option for the edge split with the contact curvature. Click the curvature symmetry plan. Click the point on the curve drag with the arrow handle to pull away from the approximate part shown in figure 37 to 23. Click the second curve, then click with the two move to the second point of the way, similar with the first point. When you're finished, then the part should be looked similar to 37 to 24. Save the file and give it a different file name. Alright, the bottom line, in the reaching with the direct editing tools, have them received lots of the high press marketing attention for the how of the CAD tools dedicated to the work primarily with the direct editing tools aren't going over to take the tools of the professional who the design model for the production. Anything that you the primary with the design CAD specialist for simple editing, simple content, step development, possibly even downstream data consumer the stuff of the FEEA and analysis for the computer numerical control machinist. Direct editing tools are available to Solidworks are powerful, but they become more powerful each of the release. Although they must be applied with the import data, they can also apply with the native Solidworks data. This brings up the question of the best practice of the duplication effort that sometimes chain would involve the editing feature for the near the top of the long feature for the tree that can time consumably compare with the simple move of the couple of faces. Familiarize yourself with the existing import-export option. Use the model without errors for practice. If you have another CAD program package available to use that for the practice as well. Master open an assembly from one of the chapters assembly, export it, and import it to see how it behaves when you get it. The practice export import is called the round trip. This one we can verify the software has written a good output data. Be aware of the import assembly will save the automatically named parts on your hard drive. Make sure the file names are not overwriting or causing conflicts with other part files. Master the direct editing feature, move face, delete faces. You can also perform any function that effective values rather than features. Take Chapter 37 of the CAD setting, directing, editing, solid part practice, removing files. Use the delete face feature for the deleting patch option without using any history-based tricks of the rolling back suppressing part with a simple loop like a filleted edge and pie-shaped cut with out of the web and the part. Remember that unlike true direct editing CAD tools, SolidWorks leaves a history-based feature every time you use delete face. Chapter 38, using plastic features.